Okay, so this is the ILM, and out of this, we just want the trig stuff, trigonometry stuff. We're not producing or making any miters. And if you don't know what a miter is, it's taking straight pipe and making elbows out of it. Okay, so that's what they do. So anyhow, you can see they have in this picture right first, they show miters in here. And these miters, as you can see, is just straight pipe, cut, and welded together. This one down here shows a one, two, three, four, um, five or four miter project, as they just have to fabricate sometimes elbows. And we use trigonometry to get to all of our numbers, is really what it is. So we're going to, well, miters actually permit odd angles and can replace expensive stainless steel fittings. And this is why they want us to use these, but it's more for steam fitter pipe fitters. But these are the objectives right here. And what we're going to do is we're going to use trig to solve right angle triangle problems. We are not going to do cut angles, but we will talk about it just a little bit, just so we have an idea of what they're saying in this ILM. Now, as you can see, it says in here, this is a second-year shop project. This is for steam fitter, not for us plumbers. Okay, so that's where I got this. Now, objective one, trig. Trigonometry means the measure of right angle triangles. So any triangle that we use will have a right angle. Always, always, always. And the right angle is 90 degrees, yes? Every single triangle has 180 degrees inside a right angle. Well, that's not a right angle triangle, but a right angle triangle makes up 180 degrees. So once we know two separate angles, we can figure out the other angle. So basic components of trig is necessary and a real asset. And it says for steam fitter, pipe fitter, but I would say for us too. So what that is terminology. We need to know the terminology if we want to know how to solve for trigonometry. We need to know the terminology. As you can see in this picture, let me just get it a little bigger here. In this picture, it shows the angle right there. And if that's the angle, then this becomes the side opposite. This becomes the side adjacent to the angle. And as we know, this is always the hypotenuse. So just to get us into that mindset of terminology and how to look at our triangles, it doesn't matter where A, B, or C is. We just need to know the correct terminology, okay? At any triangle, anytime we're looking at it. So A here, as you can see, A would be against or adjacent to the angle. So that would be A. And we look at B, it is opposite the angle, is there. And of course, the hypotenuse would be C. As everybody can see that, yeah? It's pretty easy stuff. So saying how this is pretty easy stuff, have a look at B, C, and D and see if you can answer those. And you could use the annotate button and put in your answers in there. How that is. to know exactly what the adjacent, the opposite, and the hypotenuse are is extremely important moving forward to solve anything in trigonometry. Okay? Now, you could remove your hieroglyphics there. Now, trigonometry is based upon ratios. Okay? It is based upon ratios. And it says two sides of a right angle triangle. And in this example they show here, they simply take the side opposite and divide it by the side adjacent. Now, if my mouse would work, oh, there it goes. It's just a little delayed. So it means that the side adjacent is twice as long as the side opposite in this, or we can get a ratio of that, right? Now, sometimes it's going to be shorter or longer, but dividing it out would give us the ratio of those angles, or sorry, those sides. That's it. Now, let's move on to the next page. Now, in trigonometry, we have a certain amount of functions, and this is easy to remember. We could use SOHCAHTOA, and we could draw the formulas just like this. So, S-O-H, C-A-H, and T-O-A. Now, anytime we're talking about the sine, the cosine, or the tangent, this is always the angle. This is always the angle that we're talking about. That's what those are. And you will always be given two variables to use to solve. So always one of these has to be what we're trying to find all the time. Okay? So you will always be given two variables to try and solve for an angle, to solve for a ratio, or to solve for whatever unknown it is. Is there any questions about that? So keep that in mind. SOHCAHTOA. That's how to do it. Okay? Now, for example, whatever one that you want to find out, you just cover up with your hand, for example, or your pencil, and do the operation that's present, and that would be the answer for sine. Taking the opposite divided by the hypotenuse would give you the sine, or the ratio for the angle. And now, to manipulate that triangle more, if you wanted to know what the length of the opposite side is, you just simply take the sine of the angle and multiply it by the hypotenuse. And then if you want to know what the hypotenuse is, you take the opposite length and divide it by the sine of the angle. Now, so with the use of these three formulas, we can solve for any unknown angle or any length of an unknown side. Now, we also have to have two variables at all times before we use the formula triangle. So let's have a look at this. So, it says in this picture here, we wanted to calculate the angle X. And so it says, so we need to figure out which formula we're going to use. So when we do that, we figure out, whoa, how does that happen? When we do that, we figure out what we have. Here in this example, there's the angle. So we are given the side opposite, and we're given the hypotenuse. And now we can figure out what formula triangle we're going to use. We want the angle. So it's going to be SOH. So we're going to use the sine opposite hypotenuse, SOH. Okay, so that's how you start. You start by figuring out which formula you're going to use. Now, it says in here, take the what do we got? We're going to take the opposite and divide it by the hypotenuse. So the opposite is 0.77 divided by the hypotenuse. And it gives us a number here. It gives us that 0.44767, right? Now, on your calculator, grab your calculators, please. On your calculator, I want you to type in this number, 0.44767. You're going to hit the shift button and then hit the sign button. And that should give you an angle of 26.59 degrees. Because this number that's given to you is just a ratio. Okay, so this is just a ratio, so we have to find actually how many degrees that angle is. Okay, did everybody get the 26.59 degrees? Yeah? All right. So anytime you are getting a decimal as your angle, it is the ratio. Then you have to hit the shift button and then whatever ratio you want. Is it sine, cosine, or tangent? All right. So that would make that difference. And you follow along whatever it is in the formula triangle. It says sine. Then you're going to hit the sine button. Okay. So now I want to show you something in your IPT Pipe Trades Handbook. Can you get that out for a second? If you go into the IPT Pipe Trades Handbook, you will find on page starting about 280 something, you will find trigonometry in there. Now, anytime you have an angle in degrees, okay? These are the degrees of the angle. This is how much it is angled. Now, this is called minutes. This is minutes. Because 1 degree is based on 60 minutes. So here, if we have 30 minutes, it means a half of a degree. So where it has 1 with 30, it means it's 1.5 degrees as the angle. If we have 2, so the degree is 2, 2 and 30 means that's 2.5. Because in the pipe trades, we're not going to do anything other than a decimal of a half a degree. Okay, we're not going to have whatever. If we do it on our calculators, we will have a little more precise. But for in the field work, that's what the IPT book is for field work, we're not going to go any more than a half of a degree. And they call that 30 minutes. So while we're here, I want you in your calculator type 5.5. So 5.5. And then I want you to hit the tan button. See what you get. 5.510. So we're going to go 5.5 on this line and we go to the tangent. Did you get this number right there? Yeah. Okay. So the IPT Pipe Trades Handbook is an easy way to figure out the ratios of angles because they're all given here, right? If you know what your angle is, then you could find it out. Now, on your calculator, I want you to type 45 tan. 45 tangent. Should come out to 1, yes? Well, if I look in my pipe trades handbook and I go to 45 degrees, here we are, 45. Oh, no, that's 45, 30. That's 45 and a half. I'm going to go 45. There's 45. And I go to the tangent table, and we could see, there's the tangent table. We could see that the answer is 1. 45 tan is 1. So now that gives us a ratio of what the other side or the other angle and the side lengths are. Okay, that's what it's worked on, and that's what it's based on. Any questions? Okay, let's do some examples here. Okay, we did those. Let's have a look at this page here. Now, I want you to find out these particular angles. In here, we're looking for an angle. I want to know the appropriate angle for that. I already know that this should be about 30 degrees. I don't know why I remember that, but I know what the tangent of a 30-degree angle is. So let's do the rest of these. Take a minute and write them down. I will write them down as well as we go, just to make sure you guys are getting it correctly. Yeah, pretty close. So that's 34.959, right? So yeah, 35. Remember, you have to go shift. Type in the number 0.5774, shift 10. Okay, that's how to do it. And I know this is a little asinine and not very, appropriate of your time, but it's great practice to figure out when you have a decimal, you have to hit the shift button to get the actual degree of the angle. So that's why I'm having you practice it. They're all degrees, yes? They're all degrees of an angle. That's what these are. Now, I want you to either use your calculator, the IPT book, and go into the next one, exercise 3. Find the ratio number for these. So 10, 10. So that's all you have to do is hit 10, 10. And the ratio comes out for this one something like that. And that's the ratio of that angle.
So when you find the ratio, you don't need to hit the shift, right?
No, not for this one. You hit the degree
Okay.
angle and then whatever it is you want. Yes.
Okay.
Okay.
Yeah.
See? Excellent. This is good. Yes. Right? Is there any questions about this? Is there anything that you cannot do here? Everybody's got this?
So
Excellent.
when you're finding the angle, you hit the tan and then sing co or tan. And if you're finding the ratio, you just hit the buttons with no shift.
Correct.
Okay.
Yes. Okay. So now that we have that down, okay, now you're going to have to just remove all your Sanskrit there. Thank you for that. Now, let's have a look at A here. And we want to know for A, we want to know X. We want to know the degree of X. We want to know what that angle is. So the first steps in doing this is realizing what I have. So I have a side adjacent and I have a side opposite and I want the angle. So now in my head, I can go Soka Toa. Which one am I going to use? I am going to use this one. I'm going to use TOA. Because that's what I have. And I want the angle. Okay, so this is the first steps on solving anything in trigonometry, is finding out what you have and what you need and using the right formula. So now it says I have the O over A, so that's going to be 185 divided by 420. Let me just type that in. And that comes out to 0.4404. And that's a ratio of the angle. Now I have to go Shift and hit the tangent button. And it gives me an angle of 23.77 degrees. Does everybody see how I got that? Excellent. Let's do B. So in B, I want the angle. I want to know what this angle is. So I have the hypotenuse and I have the side adjacent. So now I got to figure out what formula that has A and H in it.
Ha.
Yes, that's right. So that formula is CAH. So it says take your opposite or adjacent, sorry, and divide it by the hypotenuse. And that comes out to 0.78688. And now hit the shift button and cosine, and my angle is 38 degrees, 38.1. Let's do the next one as we're down here anyways. We have the angle. Look, it's given us the angle. We want to know the side B. So I have the hypotenuse and I have the side opposite. What formula has the hypotenuse and opposite in it? That is going to be SOH. Right? Now it says take my angle. The angle is here. So you have to, in your calculator, go 48 and hit the sine button. and then times it by 550.
Oh, okay. Okay, Mr. Doug. Okay. Okay.
And this B should equal 408.73. This next example shows we want to solve for C. I'm given an angle and I have the side adjacent and I want to know the hypotenuse. So then I figure out what formula has the adjacent and the hypotenuse in it. That is CAH. And C is the angle. So that's 65 cosine. And that actually should be divided. So 8 divided by 65 cosine. So 8 divided by 65, hit the cosine, and then hit equals, and you should come out to 18.929. Is everybody understanding how to do this? It's not too bad once you identify what it is that you have and what it is that you want. So as everybody trickles back in to the room, I'm just going to put up the answers on the screen here for these, each individual ones. A and D are done. I'm going to go to B next. And the variables that we are given is the hypotenuse and the opposite. So we will use this formula right here. And so it says take the opposite, 363, and divide it by the hypotenuse. And then the answer of that is, so 363 divided by 650 is 0.558, lots of decimals, and then hit shift sign. And that gives me my angle of 34 degrees. We're going to do C next down here. And our variables are the hypotenuse and the side adjacent. So we're going to use CAH as our formula. And it says take your side adjacent and divide it by your hypotenuse. And that equals 0.936. Repeating. Shift on your calculator cosine. And you should have an angle of 20.5 degrees for that one. For D, here's the answer here, or 49.49 without putting it into a fraction. Inches. E, we're going to do E next, and the variables we have are the hypotenuse and the angle. And we want the side adjacent. So we'll use this formula triangle where we take the angle 67.5 cosine, hit the cosine button, and then times that by 840. Which gives me 321.5. Or, yeah, it's almost 321 mils. And now F, the variables we have is the angle and the hypotenuse. We want to find the adjacent. So we will use this formula where it says take the hypotenuse and multiply it by the ratio of your angle. So that's going to be 30-degree cosine times 300. And that gives me C at 260 mils. If I round it up. 260. Is everybody in agreement with those numbers? Everybody got those numbers? Excellent. So happy for everybody. All right. Now, to continue on a little bit here, to continue on in this ILM a little bit, it kind of goes by step, how to hit the shift key and then the sign button. Okay, it tells you to do that. And these are the functions on your calculator. I think we have those. And it shows more examples in here. So if you want more examples, you definitely go through this ILM. I don't think we need any more. I think you guys are pretty okay with doing these. So which brings me down all the way to this objective 2 about miters and cutbacks. So cut angles. So miter fittings require to calculate the cut angles and cut back with the use of trig. Okay, it's not complicated, but it does require some accurate calculations. So the cut angle is the angle required on each piece of a mitered fitting. So for example, if we're doing a 2-piece miter 90-degree, as you can see, we only have 2 pieces to make that 90-degree angle. So in this example, you take the angle of your cut, which is 90, and divide it by the number of welds times 2. So the number of welds would be 1 weld right in here times 2, which makes it 2. So your cut angle is 45. And that's what this is up here. Pretty straightforward stuff. Now, it gets a little more complicated when you start doing 3-piece and 4-piece mitered 90s. But that's not what I really want to talk about. What I want to talk about in here is the cutback. Now, the cutback is the measurement from the center line to the end of the cut angle. So this is what you would cut here. This is the cut angle line. And this would be the center right here. So this piece is called the cutback. So this is where you would wrap around and put your mark on your pipe right in here with your wraparound. And then you would determine your cutback angle according to this. So you would get this measurement, and that's where you start your cut. You would get this measurement, and that's where you would finish your cut. So then you could draw a straight line on that piece of pipe to know exactly what angle to cut. Now, if you have cut any kind of pipe with a cutting torch, you know that this can be quite fun and difficult, right? So that's all I want to talk about, but the cut angle in here. Now, for example, as you can see, this becomes the cutback. And the radius, or the radii, is based upon a circle. As you can see, that's a bad circle. But you can see that's a circle, and this would be the radius. As you can see, that's how they call it the radius, right there, right? And then if we get some certain measurements, we can then use trigonometry to figure out our cut angles and our lengths of pipe. All right, so that's really how they do it. And I want to show you over here this example. It shows you how they did it. So they gave you a radius of 16. And then once you have the radius of 16, and if you know this measurement, you can figure out these measurements using trigonometry, because you can also have your angles in here making up 90 degrees, right? 15, 30, 30, 15. And that's all they're talking about in here. And we get all the way down to, let's have a look at this here. Now, if we didn't know this measurement, if we didn't know what this was or what this was, we could simply take our radius of 254, that's this line, with our angle, and we could figure out this. So we want over here, we want the side opposite. We have the side adjacent, and we have the angle. So we can use the formula TOA, where we take the angle and we multiply it by the radius here. So it's going to be 20 degree tan times 254. And that comes out to 92. And they round either up or they round down only to the half degree. Okay? Only to the half degree. All right? And that's about it. Let's just see what else we have in here. Now, in this situation, we want to know this cutback distance, and we can calculate that using trigonometry. So as you can see, this is a 30-degree angle in here. So this is 30 degrees right here. We know this distance right here because this overall is 4.5. So that's going to be 2.25 with a 30-degree angle. So we can figure out what the cutback distance is just by using trigonometry. Because the tangent of a 30-degree angle is 0.5774. Well, I usually round it up. So we take the distance here, we divide this by 2 because it's only 2.25. That measurement right there is 2.25, 30-degree angle. We could find out the end of that, and it shows you how that's done there. So quite frankly, that's everything we need to know. It goes on to tell you how to do a miter itself, and they have calculating that, but we don't have to do that.